Question 1 of tutorial 5. Here is our differential equation. According to the method that we presented, first we should compute the complementary equation. That is taking the left-hand side and setting it to 0. Using the key theorem from the previous tutorial, we see that YC will be of this form. There's only one real root for our characteristic equation, and from this we obtain the corresponding solution YC. Now we need to make some observations about how we should obtain the particular solution. G of x is 1 plus x, so it is a polynomial of degree 1. Therefore, we observe that if we differentiate g of x, the corresponding derivatives up to order 2 are going to be polynomials of degrees less than 1. Therefore, we can make the choice for yp as a polynomial of degree 1. That way, when we compute yp double prime and yp prime, these will still be polynomials and their degrees will be less than 1. Then we will substitute everything into the left hand side, and you see that if yp is a polynomial and consequently yp prime and yp double prime are also polynomials, then what we would have on the left hand side would be a polynomial, and not just any polynomial, but because the derivatives are polynomials with degree less than 1, but yp is a polynomial of degree 1, the left hand side turns out to become a polynomial of degree 1 with some undetermined coefficients, which should be equal to, upon taking the sum and upon substitution, to the right hand side, g of x. So we will take yp to be a linear polynomial, and a and b, they will be our undetermined coefficients. We need to find out what they are. When we differentiate, we see that yp prime is just a, and yp double prime is going to be 0. Then, having these pieces of information, we will substitute them into the left hand side of our differential equation. When we compute, this is what we want. We will have the left hand side after substitution to be this, and it should equal to g of x, that is x plus 1. When we compute this, we see that at the very end we would obtain a linear polynomial on one side, which is equal to g of x. At this stage, we would compare coefficients. We look at the coefficient of the x term, and we see that 9a should be equal to 1. The coefficient of the constant terms on both sides would give us 6a plus 9b equals to 1. And then we can solve these two equations simultaneously, and this will give us a equal to 1 over 9 and b equal to 1 over 27. Therefore, we have obtained the general solution to our differential equation. We take YC, which is what we found from the first part, and add to it YP. Knowing the values of A and B, we see that this is the general solution. 1 over 9x plus 1 over 27 is YP, and this is YC. As we stated, The only places where you should have arbitrary constants is in YC. That is over here. No arbitrary constants in the particular solution. This solves question 1.